The key components to our pump system will be, of course, the pump, this being a small submersible sump pump. To this pump, I have simply added the hose adapter and added the connection so that I can use my 2-wire automotive connector. This pump costs in the area of $30 to $50. Another key component to our pump system here is the solar panel to collect the electricity. It will simply charge the battery that we will drive the system with. This is a 100-watt solar panel. If you can notice, it's about 36 inches tall and 26 inches wide. The reverse side of the solar panels have, of course, I'm always interested in the information on the back. You can read that. It comes with MC4 connectors, and we will use those in connecting up. Maybe the most time-consuming part of it is building the rack that supports the solar panel. I will prepare it so that the rack sits on top of a steel post. The rack for the solar panel is made out of 1.5-inch angle iron. It's a lightweight material. You can see I have a 2-inch pipe on an angle that was designed so it will slide over the top of a steel post. The panels already have holes so that we can use them for installing the rack. I will attach it and set it on a post for you. Okay, we now have the rack attached. And it can be set on the top of a post. You'll see I have used some additional holes in the rack. These will be used for restraining the wires that I use going into my voltage controller. This is the controller that maintains the proper voltage going into the battery. When the battery is full, it will then reduce the power going in and not overcharge our batteries. The voltage controller is really not difficult. You see the connections here on the bottom. The left two come from the solar panel, the positive and the negative. The middle two go to the battery, positive and negative. And the right two go to the load, positive and negative. I will help you see how we will wire those in here in just a moment. Upon checking the leads with the electric probes, I found that this was the positive. It had a red cap on the upper end anyway, and it will go in here. I cut the end of it off, and it will go in the negative side so that I can have a disconnect from the solar panel to the charge controller as it requests. Now you see the solar panel connected to the charge controller, but the negative lead is disconnected, but I can simply connect them together once the battery is in place. The voltage controller asks specifically that the panels not be charging on unless the battery is connected first. For making the connections to the battery, I'm using a 12 gauge low voltage direct burial wire. It's designed for using solar lights throughout people's yards and such. I have about enough to go down the post to the battery, and with 4 or 5 feet of space to spare. I think I have about 12 foot in the length. The battery wires are connected. The opposite end of the battery wires, where the battery will be attached, are fitted with loops 5/16 to go over the marine style batteries that we will be using. As you can see, I have now added the output wire. The red and black wire go to the 2-pin connection. This is where I will plug in the pump or whatever output that I am using. Notice that the red wire is in the female configuration, the black wire is male. That is so that if for some reason there's a connection to ground, it will not short out the system. I have now set the panel and apparatus all onto a steel post. Battery is connected, and we will look at it says it's already at 13 volts. It was already charged when I brought it to this panel. Notice that it just shows the battery and the output. I will connect the solar panel now to make it start charging. Once I connect the solar panel with the MC4 connectors here, you can see that it charged to 14.4. That's the maximum that it will allow the battery to be charged. I am now ready to put the pump system into operation. I have now moved the system back in the shade, because out in the sunshine the contrast is just so bright that you cannot see or hear much. The pump is in a bucket here. It will be running empty. I will take the plug and plug it in, and you should hear it. The system seems to be working fine. I will now work on a switch for the pump so that when the tank gets full, it will automatically shut the pump off. To make a float system work for a system like this, and the switch to go with it, I'm using small stainless steel floats. These are just two of different lengths, and an automotive relay. I like as high an amperage relay as I can get. Originally I was able to get 80 and 90 amp relays. These are, I believe, 30 to 40 amp relays. The pump can draw as much as 13 amps. Therefore, I think that they're still adequate and serve very well. It's a process of placing these in the right configuration to make a good float switch. To protect the relay, I am using a piece of 2-inch PVC pipe. The relay is inside the pipe in this configuration. This goes to the float, and that is the power in and the power out wires. Those connections are all made. Inside the PVC pipe, a cap will be placed on the end of it to close the top. The bottom will be left open. That is so that heat can escape, because there's a little bit of heat generated around the relay when it is operating. Okay, we now have the switch attached. See, the switch is attached. Goes to the power. And I will simulate the pump switch calling for water. Here we go. You hear it? It's just that easy. That small relay activates the system to turn the pump on and off.